So we've got a diagram drawn on the board to show you whether they attract or repel. So on this one, we've got a north and a south pole. So just like the Earth's magnetism, it's drawn to the north. And this one has a south and a north pole. So we're going to draw arrows to which way you think this would happen. And if we have a south and a south, that's going to repel. So they're going to push away from each other. They're not going to be drawn to each other. They're going to push away. And so we can show that with our magnets, that you don't want them, see how I can't get them to stick? They just bounce off each other. Even with the strings on them, they just bounce off. They don't want to stick together. So that would be a south and a south, or a north and a north. Anytime you have the same magnetism, whether it's a south pole to a south pole or a north pole to a north pole, they're going to repel each other, which is to just push apart. Now, if you have a north and a south with a north and a south, the south and the north will attract each other. So they will actually, they should connect when we have that happen. And I'm going to try not to pinch my fingers. So be careful when you're using these magnets, because they will pinch. And you see how those connected without any problem. They pulled toward each other. And I can actually just make those pull toward each other like that. So that is a south and a north, or a north and a south attraction. So anytime you have two opposites, this is kind of, I think of magnetism as opposites attract. So when you're talking about opposites attract, they're talking about a south pole and a north pole of a magnet, because otherwise the same will repel. So if I want to flip that magnet over, and no matter how hard I push it, it will bounce off. It will not attract, but it will flip around to attract itself. So that's always that's the attraction.